Hello, I'm Katharina Hundenburg, a PhD student at Lancaster University. I'm working on potatoes and the response to drought and soil compaction. Today I'm going to tell you a bit more about the drought side of my work and why I'm at the moment at the research center in Jülich, working with the researchers here on a certain project. Potatoes are the fourth most important crop in the world. They are usually grown for the local market, and since they're grown and eaten all over the world, that means that they have to grow in various different climates. So they have to be adapted to very different conditions. Unfortunately, the varieties that we grow in Europe are not very well adapted to drought. Even in a country like the UK that is known for its very rainy climate, potatoes have to be irrigated during the summer season to ensure proper yield. Low water availability during the summer month will become an even bigger problem with climate change, because the summers will get hotter and drier. So farmers need a solution for that. In the short run, that means a water management tailored to the crop and the site, and in the long run, that means breeding varieties that are more tolerant to drought stress. To achieve both of them, we need to understand the underlying mechanisms of potato drought stress responses. Potato plants are interesting because they have a storage organ, the tuber. So they do produce sugar and carbohydrates in the leaves and then send them down to the tuber, where they are stored in the form of starch. This starch is then kept in the tuber and provides the next year's generation with carbohydrates to grow. However, this storage organ might be a bit more than that. If we cut a tuber open, if we want to cook, for example, we realize that this tuber still has a lot of water in it, even though it might be stored for several weeks already. So, if the tuber can store water for a while, maybe it also serves as a water storage for the plant under drought stress. So it could be possible that the tuber is actually something like a little water reservoir in the soil that supplies the plant with water when the roots can't get enough water out of the soil. These potato plants were grown in the same conditions and controlled environment for 6 weeks. Now, half of them is re-watered every day, while the other half is left to dry out for 3 days and then re-watered. During the 4 days of the experiment, we are imaging the potatoes in the soil every 4 hours with a technique called magnetic resonance imaging, short MRI. From these images, we can later extract information like tuber volume and water content of the tubers. With the help of EPPN 2020 funding, I was able to come to the Research Center in Jülich to work with this 4.7 Tesla plant MRI. This will help me to find out a bit more of what happens underground when potatoes experience drought stress. We are interested in the question how the potato tubers contribute to shoot response to drought. So we also did physiological measurements on the shoot. Among other parameters, we measured gas exchange and leaf water potential during the daytime prior to the MRI of each plant.
It was dusty in December, the dry was setting in. Could see the heat haze rising off the corrugated tin, and nothing stirred out in the holding yard.
This data helps us to estimate the stress status of the plant. In addition to that, it allows us to put the data we gained in the PoTuWa experiments into a wider context, because I collected similar data from potatoes in the field and in other controlled environment experiments. Taken together, these experiments provide a unique data set that allows me to understand a bit more about potato drought stress responses.
It was reckless, it was real. was love in the time of drought.